Hello, this is Dirk again, and this time around I wanted to talk about how to fast-track assigning a material to a model that has been imported into Unreal Development Kit. The model in question here is the F16 model that I showed in an earlier little tutorial. It's an OBJ file, which my version of Windows is showing me with a Visual Studio icon for an OBJ file. It's actually a graphical 3D OBJ wavefront file, and it's associated with a material file that's just an MTL file, which is a text file. One of the notable things about this material file is that it makes use of RGB images that are not as widely supported as certain other image formats. And so to make this thing compatible with Unreal Development Kit, the first thing you would need to do is convert this RGB image file into a TGA file. I'm assuming that you have graphics semantic installed, just as there are other image utilities which will do the job equally well. I'm going to get the properties of this image file just to get the path at which it has been stored, or at where on the hard drive the folder is located, so I highlight this in the properties dialog of the file. I have a mouse that has a fast key to copy, otherwise you would right-click and click on copy, then we will not be needing this particular dialog box anymore. We open up the command prompt, we change directory and open quotes, we right-click and we paste the destination directory that we want to change to, and now we give the following graphics semantic commands, in my case, gm convert f16.rgb to f16.tga. That was fast. And of course, Windows quickly updates its Windows Explorer window to show that the TGA file has been produced. Now we'll do the same thing for the shadows file. gm convert f16-shadows.rgb to f16-shadows.tga. It will tell me immediately if I've misspelled the name. No, it's happy, and I've got another TGA file there. So that's a question of converting very simple texture images. And now, yes, I can in fact open them in Photoshop if I double-click on the F16 TGA file. This is the texture image we're working with. Nice and simple. And one of the facts that we have to recognize at this point is that the actual OBJ file has been properly UV mapped to the RGB texture files in question, so that it will therefore be exactly texture mapped to the TGA files in question as well. So this UV mapping must not change if we're going to ignore the material file. Now the material file in question is F16 MTL because its name before the extension always matches the OBJ file's name. I'm going to open this up in the text editor. I like using Vim, and I'm going to show you what's happened here. Inside this OBJ file, MTL file, material file, there are these paragraphs which are sometimes referred to as stanzas. The fact is that we're not studying Shakespeare here, so they're really neither paragraphs nor stanzas in the literal sense, but they're little blocks of text that normally tell the graphics program how to define each of these materials. They begin with new material, NEWMTL, and the name of the material to be defined, and each of these stanzas ends with a line that explains from which texture file, image file that is, the material in question is supposed to be grabbing its diffuse value. So the strength of the diffuse color is 1, and the map, the image map from which to grab the diffuse color, has simply been identified as F16 RGB. But wait a minute, we're not going to use F16 RGB, we're going to use F16.tga. Therefore, we must edit each occurrence of these image files to have the correct file name extension. Some of these paragraphs do not have an image file following them, and they simply state a set of material parameters with no texture image associated with them. Well, I've already done the work previously. I don't want to drag the audience through a whole bunch of endless typing on the keyboard, so that I created a file called det, which is actually identical to the file called f16.obj, just so that I can have a material file called jet.mtl, and this is what the file looks like, or at least the beginning of it when it's been edited. So right here we've simply changed all of these .rgb extensions for the texture image to .tga extensions I've been but I have not changed the definitions of the material names because they're being referred to by the OBJ file. So if the OBJ file wants to fetch material AC3D mat1 underscore f16.rgb, the material will still be defined as such, but we're instructing whatever graphics program we're using to use the TGA file as the source of the diffuse channel. So that work has been done for you, and I'm going to demonstrate that this technique by itself works by opening the Apex Physics Lab, and we were greeted by our splash screen. We go into destructible. We're creating an Apex destructible, we import the 3D mesh, and this time instead of clicking on F16, I'm going to click on net. And what I'm automatically doing is I'm asking it to calculate, well, never mind, I'm getting ahead of myself here. I'm opening the file called mesh. And so one of the things we notice is that there are still error messages produced by the Apex lab. And if we look at it carefully, we'll discover that it was attempting to open texture images that did not exist. For example, what it says right here is failed to open texture file AC3D mat12 dot using default fallback. Well, what that means is that for the stanzas that did not have a texture file stated at the bottom of the paragraph, Apex nevertheless expects for there to be some sort of a texture file automatically that has the same name as the material that's been defined, but in this case it hasn't put any file name extension. So it's neither .rgb nor .tga because no texture file was specified. This is a quirk in behavior of Apex which we can safely ignore, Apex Lab. So if I rotate this fully textured image, we'll notice that contrary to what I showed in my previous video, it does in fact display a set of texture maps. And what we'll notice is that if you go to the graphics part of the control panel, some of these things have in their names the RGB, and others don't. So any material that doesn't have an RGB in the system doesn't have a texture image, whereas materials that end in .rgb have our material image that has been recognized as a PGA file now, differently from the previous demo. So the thing is, I can open this up in the Apex Lab, but there is one unfortunate thing here that I must respect, and that I've tried to find a way around, and I found a way around. It actually tells you in a little pop-up that the only thing that will get inserted into the output file, into the asset, is in fact the name of the texture. So whatever we're doing here, it's telling us in a little pop-up that the name of the texture is the name of the texture. So it's telling us in the little pop-up is these are all simply stored as strings in the mesh. It's possible to change the name, but it will not be possible at a later point to get the Unreal Development Kit to import the actual named materials from an NDL file. So I'm going to skip ahead to where I created my destructible asset, and because that part was already, I already explained that part in another video I shot. So I'm going to open UDK, and let's see how well behaved it is on opening. Very well behaved. We close the little splash screen, and so I use my old trick, which I've done quite a few times by now. I'm going to import, and I've got a separate little folder that I've copied my output files to. Sorry, it's not under documents, it's under pictures. My pictures, CGI local, and I've got it under Apex. So I've got the binary and the XML version of the destructible asset, and I've got my picture files as well, my texture, images as well. So I'm going to open the binary format file here, and with any luck it will import properly. And already, as it's showing me in this little preview thumbnail, the materials will not be right. If you look closely, you'll notice that it has this gray and blue metallic finish on it that in no way reflects what was actually specified in the materials file. So what I will do is I will also import the texture image, which is a TGA file I showed you before. And again, I get a dialog, but this time I have properties that I can alter. And one of the things it will ask me, even as I'm importing, is do I want a material to be created to go with the texture image? So I click this, because I don't just want a texture image, I want an associated material. And I click OK to import. And there is my material, as well as my texture image. Now, if I wanted to edit this texture, the material in the material editor, what I would see right here is that, in fact, I have a UV mapped texture image, but it's only providing output to the diffuse channel. So there's a diffuse color channel coming from it. I suppose to make this a little bit more interesting, I could also try to create an output path that goes to specular, in case I wanted it to be specular, but then this is the one texture image that I have for everything. I've just edited the material. It would be nice if I could get the position of the little texture image box to change relative to the node that defines the material. I haven't completely gotten around to that. I can try. I've selected something, but I'm moving everything in the window, so I'm not dragging this with respect to the other one. Alright, so I edited this so that it's not just my diffuse component, it's my specular component as well. And I'm not going to touch any of the parameters. Would you like to apply changes to this material to the original material? No, we'll lose all changes. Yes, I would like to apply. Okay, so I have this. The idea now is I'm going to open up my destructible by double-clicking it. And my dialog here indicates that it has assigned default materials to all of its 30 materials. Well, I would like to assign my custom material to all of them, so I've selected it in the content browser. And now what I do is I use the little left arrow. So first there'll be a slight delay, and I've changed it to F16_material. I go through all of them. 4, 5, 6, 7, 8, 9. We're at number 18. We continue down. We got to number 18, and now number 25. It's a bit tedious, that's how it goes. So now I've assigned all of my materials from number 0 to 29 in the array that had simply been given names before. I've assigned them to my one custom material that I created. And now if you look at this little preview icon, already it seems a lot more like it's supposed to seem. So let's try dragging this into my scene. So here we go, there it is. I'm going to bring it up from the surface. This is raycasting on the part of the UDK editor. It follows the cursor that's on the screen into the scene, so that now the cursor corresponds to a position somewhere in the sky. I'm going to scale the little dot I've created to prove that it is in fact what it's supposed to be. I'm going to say that this is my dead fighter, and that's not very promising just yet. We're going to see in a moment whether it is or isn't in fact what it's supposed to be. Now that the light thing it differently, it looks a little bit more like they did the right thing. It's no longer looking at a surface color. We're turning 180 degrees this way. So here it is, and now we go back to translation mode because we want the ground plane that's underneath it that it's casting shadows on to disappear into the ground. Also, the fact that the ground plane is physically intersecting with the world will prevent it from being dislodged if I use this destructible as a destructible. So this is my F16 properly texture image, and almost flat shaded. The fact that I've given the same color as diffuse and specular isn't really doing that much for me in terms of accurately shading, let's say, the canopy or the intake or the flame that's coming out the back, and that is better than having a completely random material on there. Now, if I bring up the content browser again, I can once again look at the vehicle. One of the vehicles happens to be called a Scorpion, so let's put one here. There's the Scorpion. I return the content browser to its original condition, and I decide to play my game. I hit play in the active viewport. So the idea is that once again I'm going to approach this almost flash-shaded jet fighter image. It has a much better material textured vehicle in front of it. I hit E to enter the material. Well, that's better than what I had before here because, okay, let's see what happens. Well, more or less what I wanted. Escape gets me out. So that is the fastest and dirtiest way to apply an existing texture image, but not really the defined materials, to an asset which has been imported into Unreal Development Kit editor. So I'm not going to say any of this because I have slightly better versions on my hard drive already. My CPU is pretty hot here. It's at 59 degrees, 58 degrees Celsius. One of the things I've noticed UDK editor does is it seems to run both the GPU and the CPU at 100% usage, so that if you have a GPU or a CPU that can't handle high temperatures due to full power usage, you might think twice about doing this type of an exercise. Right now the GPU is gradually cooling off. The GPU core voltage has been lowered to 0.875 volts, so it's got a chance to cool off now. And I think that means that I may as well cool off too. Thank you, bye-bye.